Welcome to Sundar's lecture, and this is lecture number 14. In this lecture, we are going to see nodal voltage analysis method by KCL by applying Kirchhoff's current law, right? So, in the last class, we have seen this problem, right? So, we would have found yes, nodal voltage analysis method. This is actually lecture number 12. We have continued this lecture. This problem in the 13th lecture. So, nodal voltage analysis method we have solved by using the matrix method. Now, we are going to find the current in all resistor for the same problem using KCL. By applying KCL, we are going to find nodal voltage analysis method, right? Now, you get a clear idea about what is mesh current analysis method and nodal voltage analysis method, right? In mesh current analysis method, you take this same problem, you have three loops, right? The ultimate aim in mesh current analysis method is to find what is I1, loop current 1, loop current 2 and loop current 3. How many loops are there? That many currents you should find, and with the help of that loop currents, you will find what is the current in all the resistors. So that is the principle of mesh current analysis method. If it is a nodal voltage analysis method, it is very simple. Instead of finding how many loops are there, you need to find how many nodes are there. And you see in this problem we have node A and node B. And what is the ultimate aim? What is the ultimate aim? You see this is node A, this is node B. Ultimate aim is to find what is node voltages. That is VA, VB. Here we have a reference node O. So with respect to O, we need to find what is VO and what is VBO. Simple. If you find what is VO and VBO, then it is very easy to find what is the current in all resistors. What is the, oh fine, 1 minute. What is the current in all resistors? That is what we have seen in the lecture number 13. So in this lecture, now in this lecture, we are going to see the same problem. We have taken the same problem, right? So we have taken this and we need to find what is the current in all resistors. That is the question given to us, right? Now what you have to do, if you see a problem, this is nodal voltage analysis method. So you simply see how many nodes are there. It is simple, right? This is node A, this is node A, and this is node B, and this is the reference node. This is the reference node. Oh, this is reference node. There is no difference. These 3 points should be same. Now, you see, we are going to apply KCL at node A and node B. Simple. So, what we need to do, we need to apply KCL at node A and node B. Before applying KCL at node A and node B, what you need to know? You see, this node has 3 branches. Then you assume 3 currents. Simple. You assume 3 currents. That direction of current is up to you. You can assume it in any way. See, I will assume this is I1, first current, first branch current, and you have another branch here, right? You have another branch here, right? So what I will do, this is I2, I am assuming. You see there is another branch here. Now what you do, you just assume this as I3. Say I have assumed 3 currents. Now you go to this node B. You see there is a one branch here, there is another branch, there are 3 branches again. You see this branch I have assumed already, that is I3. So you don't need to assume again. It is already there, I3. Now this branch current, I am assuming it as I4, and this branch current I am assuming it as I5. Simple. This current directions are up to you. You assume this way or that way, no problem. That is not at all an issue here. Anyhow, now what you do, you apply KCL. Simple now. Now it is getting very simple. See, apply KCL at node A. Apply KCL at node A. See, in node A, you put equal to symbol. what are all the currents coming in? I1 is coming, I2 and I3 are going away. So what you need to do? You need to write I1 is coming in, I1 is coming in, and I2 and I3 are going away. Right? So this is expression number 1. And what you need to find? You need to find what is I1, I2 and I3. That is the ultimate aim, right? So you need to find. So first I will find, to find I1, to find I1. So how will you find I1? See, this is point O, this is point A. And if I travel from here to this point, then that is what? It is VAO. And then you travel, you get this value. You see, I am going to write VAO expression. So start from this point, you go in this way, come here, you are traveling from minus to, since your current is in this direction, you try to understand, you are writing the VAO expression. So the current directions may be anything. I'm not going to consider the current direction. See, it's, you have to understand this point very clearly. So I am going to write what is VAO. So what is VAO? You have to start from O point and you have to reach point A. That's all. That may be any way. You can travel this way or this way. That everything will give you VAO. But I need to cover what is I1. Right? So what you do? You start from this point, come here. So from minus to plus I am traveling. So I need to put plus 10, plus 10. Then I am traveling in this way. See, this current is same as I am traveling. My travel direction and this current I1 is same. So what you need to do? You need to put minus 2 into I1. Minus 2 into N, that's all. I've reached point A, right? I've reached point A. So now what you need to do? So I will draw like this. So what you need to do? You need to find what is I1. That is our ultimate aim, right? So if you want to find what is I1, you bring this to I1 to other side, to I1 to other side, and VO to this side. So to I1 you bring this to left hand side and VO to other side. So you will get 2I1 which is equal to 10 minus VO. That's all. Simple. Now what is I1? I1 will be equal to what? 10 minus VAO divided by what? 2. This is expression number 2. Right? You write it as. Now we have found what is I1. And you need to find what is I2. So if you want to find I2, again you see from O you travel to A. You will get again VAO. Again you will get what? VAO, right? So if you want to write again VAO, see you travel from O to A. You see I am traveling in this way. This current is coming opposite to me. So I have to put plus, obviously. What is the voltage here? 1 into I2. 1 into I2. That's all. I have reached point A, right? So it is very simple now. Very simple. Very simple. What is this? What is I2? What is I2? That is nothing but VAO. VAO, if you just bring this 1 to other side, it will be VAO by 1. So VAO by 1 will give you what? VAO. So this will be what? I2. And then you need to find I3. You see I3 is here. What you can do? Again you travel from this point to this. Right? You travel from O to this point. You can come through this I3 current direction. I3 current. Right? So what you can do? Again we need to write what is VAO. That is an obvious way to write, since we are going for VAO. You see I am starting from this point. You see what is the voltage between these 2 points? From here to here it is VBO already, right? From this point to this point it is already VBO. We know that this is VBO. So you directly write this is VBO, then you travel to this point. From O to B it will be VBO. You travel from here, what you will get? You are going in this direction to this point. So what you will get? From minus to plus you are traveling. So you will get plus 1. This is plus 1. Then you are going in this way. This current is coming opposite to you. So if it is opposite to you, what you have to do? You have to put plus again 3 into I3. 3 into I3. That's all, you reach to point A. and that is nothing but it is VAO. So if you simplify this, what you will get? What you will get? If you simplify and you get this just I3, so I3 will be equal to, so you would have bring all this to other side. So this is VAO minus VBO minus 1, and I3, 3 into I3 would have been in the right hand side. Now you bring this divided by 3. You see, that's all. That's all. We have found what is I1, I2 and I3, right? Now you can substitute in this expression to form a VO, VBO with the unknown components, right? So we have not completed yet because we have applied only KCL at node A. We need to apply KCL at node B also, right? So we will apply now. We will apply. I'm going to take the same circuit in the other page. See, I have taken the circuit again. There is a problem. Okay, so we have taken the circuit again. Now what we need to do, you apply KCL at node B. KCL at node B. So what you will get? You put a equal to symbol. Now you see I3 is coming in, I4 and I5 are going away. I3 is coming in towards the node, I4 and I5 are going away. So what you will get? This is I3, I4 plus this is I5. So this is expression number, what is the expression number? 5. We will get it as 5. That's all. Then you need to find what is I3, I4, I5. That is the ultimate aim. You see I3 we have found already, right? You see we have found what is I3 here. So it is not necessary to find I3 here. We need to find what is only I4 and I5. To find I4. So to find I4. To find I4, what we can do? You see, this is I4, right? So you start from this point, go to B, that is VBO, we will cover I4. Simple. Very simple. We need to write what is VBO. That is the ultimate aim. Because what is this? You start from this point, go to this point, you will get VBO, right? So VBO, if you write VBO, start from this point, O, I am traveling in this way, from minus 2 plus I am traveling, so this will be plus 3, obviously. Then you see I am coming here, this current is opposite to me. So what I have to do? I have to put plus here. I have to put plus and 5 into I4. 5 into I4. 5 into I4. That's all. I have reached point B, right? Simple. Then you can easily find what is I4 from this expression. If I write I4, so what you would have done, you have to bring this VBO will be there. This will be minus 3 and this 5 would have come to the new denominator side. So this is not very clear. So this is 5. So this is expression number 6 now. So we have found what is I4. Now what you need to do? You need to find, sorry, let me draw perfectly. You need to find what is I5. I5 to find what? I5. That is the next thing you need to do. To find I5, you see you can travel in this way to B. From O to B, we can cover I5. So you write again. What is that? VBO. Simple. VBO. Start from this point, go in this way. You are traveling from minus 2 plus. So you will get what? Plus 2. And you see you are going in this way. This current is coming opposite to me. So what I have to do? I have to put plus 4 into I5. 4 into I5. That's all. So if you write what is I5, I5 will be VBO minus 2 divided by 4. This is nothing but expression number 7. That's all, right? We have found what is I5. Now you see, I know what is I3 already. I know what is I4 and I know what is I5. Substitute in this expression, you will get VAO and VBO expression. And also you can substitute these values. That means I1, I2 and I3 in this expression, you will get another expression. So you solve the two, you will get VAO and VBO. That we will see in the next class. Thank you. You go through this. Thank you.